If someone can respond in the chat box, yeah, thank you. So today is the first class for the course Environmental Chemistry and Microbiology. So this is a problem solving session uh, where if you guys have any doubt regarding the assignment questions, you can ask me. Otherwise, I have prepared certain questions which are similar to your assignment questions. So we can go through those questions and you will get an idea of how to solve your assignment questions. Uh, so I'll be solving the questions in the class. When I am when I'll be showing you the question, I would expect you guys to give me an answer if you know. Even if you don't know, I would request all of you to at least try find solving the questions. If you are able to solve it, well and good. If you are not able to solve it, I'll show you the solution and I'll tell you step by step how to solve any of the questions. Okay, and feel free to stop me at any point wherever you have any doubt. Feel free to stop and ask me. Okay, I'll try to clear all your doubts as far as possible. If I don't know something, I'll try to clear it in the next session. uh, so So this session is for the course Environmental Chemistry and Microbiology. The course instructors are Professor Anjali Pal and Sudha Goel from IIT Kharagpur, and I am Shrija Ghosh, a PMRF from IIT Kanpur. Uh, so today's session is all about acid, bases, and salt. I hope you all have gone through the lecture videos. So I have prepared certain questions based on those lecture videos and based on your assignment questions that are given this year. So we'll be solving those questions. Feel free to ask any doubt if you have. Okay. So before starting with the questions, I'll start with some common equations that we are going to use. So this session is all about acid, bases, salt, as I've mentioned, and there are mainly 5 or 6 equations which you should remember. If you remember these equations, the rest of it is fairly easy. You will be able to solve any question that will be asked from this particular topic. So the first equation, I hope you all must be familiar with these equations. Even if you are not, I want you to write these formulas down somewhere in your notebook, or like remember it somehow, so that it will be easier for you to solve the questions whatever we are going to solve in this class. Okay, so the first equation is pH is equal to minus log negative log of H plus ion concentration. So this is a very well known equation. I hope all of you are familiar with this equation. So if you know the H plus ion concentration, you can always calculate the pH, and if you know the pH, you can always calculate the H plus ion concentration. Okay, so same based on this pH equation, there are two more equations, pKa and pKb. So Ka is the dissociation constant uh, of an acid, and Kb is the dissociation constant of a base. Okay, so based on this equation, you can define pKa as negative log of Ka, where K is the dissociation constant, as I've mentioned. For acids it is Ka, for bases it is Kb. So pKb is equal to negative log of Kb, and all these logarithmic equations are with the base 10. So when you are using a calculator to solve the equations, make sure that you are using log and not ln, which is a natural logarithmic form. Okay, and then we have the Henderson-Hasselbalch equation, where it is defined as the pH, where pH is equal to pKa plus log of salt concentration divided by the acid concentration. Okay, so this is an equation for acidic buffer, and if you have a basic buffer, you can also define POH, So the relationship between pH and pOH is fairly simple. So pH and pOH totals up to 14. Okay, so if you know pOH, you can automatically calculate pH and vice versa. And you can define this Henderson-Hasselbalch equation in terms of pH and pOH. If you are defining it in terms of pH, you will use the term pK, which is, I've told you, K is the dissociation constant of acids. And if you're defining it in terms of pOH, you will use the dissociation constant of the base. Okay, so and here also you can see the concentration of base is in the denominator of logarithmic function, whereas in this case the acid concentration is there. Okay, Samadrita is asking about the responding. Ma'am, shall we speak? You can either unmute your mic and ask questions, or you can write it in the chat box. Whatever is comfortable with you guys, you can follow that. Most probably, if you write it in the chat box, I can read it. If two or three people unmute their mic and at the same time, it might create some disturbance. So it depends on you guys, however you feel comfortable. Okay. So I hope these formulas are pretty clear to everybody. There are three more equations that are there. These equations are to define the pH of particular solution. So if you have a buffer made of if you have a salt made of weak acid and strong base, you can define the pH of that particular salt as 1 by 2 or 0.5 multiplied by the pKw value. So pKw is like pKa and pKb. pKw is the where Kw is the dissociation constant of water. That is basically it's a neutral solution. So the value of pKw comes to 14. Okay. Then you have half pKa and half log C, where C is the concentration of the salt solution. So for any particular concentration of salt solution, you can actually calculate the pH. Theoretically, you can calculate the pH if you know the dissociation constant of that particular uh, acidic component of the salt. Okay, so if the salt is of weak acid and strong base, then you have this equation. If it is made of weak base and strong acid, then the equation slightly changes, where the instead of the positive sign we have the negative sign in the equation, and instead of Ka, now we have Kb, because the base is weak. So these dissociation constants, they are mainly important when we talk about weak acids or weak base, because they are the ones that are dissociating slowly. Okay, strong acids and strong base will immediately dissociate in a solution into its corresponding ion. So if you have NaOH, let's say for example, NaOH is a strong base. So NaOH, when you put it in water, it will immediately dissociate into Na plus and OH minus ions. Okay, whereas if you now let's say take a weak base like sodium carbonate. Okay, it's a salt solution, but it's also basic in nature. So if you take this, it will slowly dissociate into the corresponding ions, and because it is slowly dissociating, there is a dissociation constant involved with the weak acids and weak base. Okay, so similarly for salt made of weak acid and weak base, you have to consider both pKa and pKb to calculate the pH. Okay, so these are some equations. This is just a introductory slide. So if you know these equations, it will be very easy for you to solve all the questions that I have prepared and all the questions that are there in your assignments as well. So we'll start with the questions now. Before starting with the question, if you have any doubt regarding these equations, you can ask me, because these are the major equations. Like, I have just pinpointed the major things that you should definitely remember from this week's session, like from this week's lecture series, so that you will be able to solve, if not 100%, at least 90% of all the questions. Okay, so uh, please ask if you have any doubt in any of the in uh, you have any doubt in any of these equations or anything related to these equations. What does C denotes in these? C is the concentration of the salt. So like I've given this example, let's take this example. So Na2CO3 is a salt. Okay, and for Na2CO3, so if I ask you to find the pH of 1 molar solution of Na2CO3, okay, 1 molar solution of Na2CO3, then 1 molar would be the concentration of this salt solution, which is C. There will be a pKb value given in this question. Sorry, pKa value given in this question, since it is a salt of a strong acid, weak acid and a strong base. It's a salt of NaOH and H2CO3. Okay, so the base is strong, the acid is weak. So weak acid, strong base. So this is the case, and C will be the concentration of salt solution. pKa will be given for H2CO3, and we already know the pKw value. So you can calculate the pH of this salt solution. So for solving the, like for calculating theoretically the pH of any salt solution, if you know the concentration of that salt solution, and if you know the pKa or pKb value of its corresponding acid or base, you can always calculate the pH. Okay, anything else? Okay, so I'll start with the first question now. So the first question is, what is the approximate pH of a fruit juice containing H plus ion concentration of 3.3 into 10 raised to the power of minus 2 molar? So H plus concentration is given. I have told you the formula in the first slide. What formula should we use? So I'll give you some time. All of you, I request all of you to solve this and tell me the answer. Options are option A 8.34, option B 5.84, option C 3.62, and option D 1.48. What is the approximate pH of a fruit juice containing H plus ion concentration of 3.3 into 10 raised to power minus 2 molar? So all of you, you can use calculators, because in the final exams also you will have a on-screen calculator. So you can use your calculators, but calculate the pH. I have shown you the formula. Okay, I have, most of you are answering 1.48. One person has answered option C. Someone has answered option D as well. Okay, I'll wait for one more minute to for others to solve it as well. All of you, please try to solve it. Okay, most of you are agreeing with option D as answer, 1.48. One person, okay, there are two people now who have gotten 8.4. Okay, we'll see. Ma'am, could you please tell me why C is not needed in the last equation? Okay, yeah, Mobini, I'll answer your question. So we have one question that in the previous equations, for the last equation, we don't need log C. That is actually because it's a salt of weak acid and weak base. Now what happens is, when we have a salt of weak acid and weak base, let's say an hypothetical salt xy, where x is the x is the counter ion for the weak base, that is we have XOH and HY as the acid, and both of them are now weak acids and weak base respectively. So now what happens, this weak acid will dissociate slowly into H plus ion and Y minus ions, as well as this will be dissociating into X plus ions and OH minus ions, right? So when we have both acid and base slowly dissociating into the solution, the concentrations of all these values will be now important, will be affecting the pH. So what is the pH actually? pH is basically the H plus ion concentration, right? Log of H plus ion concentration. So final H plus ion concentration will be dependent on all these ions. So instead of taking the total concentration, so here also the total concentration is basically a club of the ions that are there for the acid and the base. Since only base is weak in this case, so pKb will determine the concentration of the weak base. For the acid counterpart, for the ion of that salt, like for example in this case we had this strong base and weak acid, so the counter ions that we'll have in the solution will be Na plus, OH minus, H plus and CO3 2 minus, right? So these counter ions will determine the final pH. Now from the pK value, from I'm talking about this equation, from the pK value of H2CO3, we'll have the idea of these ions, okay? And from the C, from the total concentration of salt, because as base is strong, it is going to quickly dissociate. So the concentration of base will be correspondent to the concentration of the salt. So the concentration of salt itself is enough to determine the pH. But in this case, since all of these are dissociating slowly, we cannot take the concentration of salt, because concentration of salt will not directly correspond to the concentration of either acid or base, because all of them are dissociating slowly. So we have to take the concentration of counter ions, and concentration of counter ions are directly related to this pK and pKb value. So I'll give you some more detail on this. So if we have let's say CH3COOH, it's a weak acid, it's acetic acid, it's a weak acid. It will dissociate into CH3COO minus plus H plus ions. Okay, it's a weak acid. It's a weak acid and it will dissociate into these two ions. So the dissociation constant Ka is actually equal to the concentration of CH3COO minus ion multiplied by H plus ion concentration divided by the CH3COOH concentration. Okay, so this dissociation constant for acid or for base also you can write these kind of equation. Okay, so these dissociation constants are also in a way representation of the concentration of these particular ions. Okay, so in case of strong ions, we don't have to define the concentration with the dissociation constant, because it will be very quick. The concentration of acid that is on the left hand side of the equation will be equal to the concentration of its corresponding ions. Okay, so in that case we don't need to rely on the Ka and Kb. We can directly rely on the salt concentration. I hope that clears your doubt. I have given a very detailed response because in the further questions you might be able to solve those questions. Okay. If anyone else has a doubt on this, please let me know. So all of you, I can see, have answered option D, 1.48. So to solve this question, you basically have to take the negative log of the H plus ion concentration, and the correct answer is 1.48. So people who have answered option A, 8.4 or 8.34 as the answer in the chat box, I hope you guys have gone through the calculation once more. If not, I will request you to go through your calculation and check if you are getting 1.48 as the correct answer. I have one more question. Does pKw value change with temperature? I mean, is it 14 only at 25 degrees Celsius? Yes, it is temperature dependent. Even pH is temperature dependent. So all these dissociation uh, constants that are given, mostly they are given at the standard temperature and standard pressure is at STP. Okay. So all these values, because how slow or how fast the ions are going to dissociate is always going to be dependent on temperature. Okay. So Swastika, I hope your question is answered. People who have answered option A as the correct answer, I hope you go through your calculation. If you are still getting the option A, let me know in the chat box. Okay. All others who have gotten 1.48, you are right. So you basically have to take the negative log of 3.3 into 10 raised to minus 2. And to solve this quickly, even if you don't have a calculator, to solve this quickly, you can see if you have log A into B, if you have something in this form, you can always split it into log A plus log B. So in this case also, I have not put brackets. So in this case also, you can see, so we had negative log of A into B, where I had split it into negative log of A plus negative log of B, and then you can only take the log of 3.3 using the calculator, which comes to 0.52. And when you have something in this form, so there's one more formula where if you have log A to the power x, you can always write it as x into log A. So in this case, we had log base 10 raised to the power minus 2. So I can write it as minus 2 multiplied by log 10. And since my base is also 10, so log 10 base 10 will be equal to 1. So this will be minus 2 into 1. That is equal to minus 2. So that's why. And negative of negative 2 will be plus 2. So that's why I've gotten here plus 2. So 2 minus 0.52 will be 1.48. I hope everyone, this is clear to everybody. Anybody, if you have any doubt, please write it in the chat box. Meanwhile, I'll move to the next question. Question number 2. The pH of a solution containing HCl is 3. Approximate concentration of HCl is. So now we have given you the pH. In the previous question, we had given you the H plus ion concentration and you were supposed to find the pH. Now the pH is given. You have to calculate the concentration of HCl. And the molecular weight of HCl is given. Why the molecular weight is given? Because if you see in the options, the unit is in gram per liter. So whatever concentration you will calculate from the pH, that will be in the units molar. Okay. So the unit for that will be in molar. From this molarity, you have to calculate the grams per liter. So molar is basically moles per liter. You have to calculate it in grams per liter. For that, you have the extra information, that is the molecular weight. I'll give you some time all of you, please use your calculators and calculate. Write the answers in the chat box. Okay, I have one answer, option A. Option A, option A, okay. All of you try to solve it. Meanwhile, I'll also solve it so that people who are not able to solve, you can follow. So we have pH given as 3. So I told you pH is negative log of H plus ion concentration. So to calculate the H plus ion concentration, you can directly write 10 raised to the power of 10 raised to the power of minus 3. Okay, so if you have log base 10 into A, so if you have log base 10 of A equal to B, you can also write it in the form that A is equal to 10 raised to the power B. Okay, so this will be, since this is minus log H plus ion concentration, so this will become minus 3 and then 10 raised to the power of minus 3. So H plus ion concentration, we found the H plus ion concentration. So since HCl is a monoprotic acid, that is, HCl is a monoprotic acid, that is, it has one H plus ion. So whatever the concentration of H plus ion will be equal to the concentration of HCl. So the HCl's concentration is also 10 raised to the power of minus 3. Now so this is in molar. From this you have to calculate the grams per liter. So you have this 36.5 grams per mole. So 1 mole, I told you 1 molar is moles per liter, right? And 1 mole has 36.5 grams of HCl. So 1 mole has 36.5 grams of HCl. So 10 raised to the power minus 3 moles will have 10 raised to the power of minus 3 into 36.5 grams per liter. Okay. So this is the detailed solution. I hope everyone was able to solve this. I can see most of you, all of you have written option A. Just check if someone has written it wrong. Okay. Okay, all of you have written option A. All of you who have responded have written option A. So I hope everybody was able to calculate it. Still, this is the detailed solution. Anybody has any doubt in this question, please ask. Otherwise, I think it is pretty straightforward. Don't hesitate to ask, even if you have a very small doubt. If you have a doubt regarding some mathematical calculation also, please ask. This is important part of this chapter. So whatever your doubt is, don't hesitate to ask. I'll try to help you out. Okay. Moving on to the next question, question number 3. If 5 ml 0.2 molar HCl is diluted to 1 liter, the approximate final pH will be. Options are option A 4, option B 3, option C 5 and option D 8. So 5 ml of 0.2 molar HCl is diluted to 1 liter. So final pH has to be calculated. Okay, I'll give you some time. All of you use your calculators and calculate. we have the concentration of HCl, we have the volume, initial volume of HCl, we have the final volume of the solution. We have to calculate the final concentration of HCl basically. Okay, so concentration of HCl will directly correspond to the H plus ion concentration. I've told you in the previous question, right? So HCl will dissociate into H plus ion and Cl minus ion. So whatever the moles of HCl will be, it will be same for H plus ion concentration. So if you calculate the final concentration of HCl, you will get the final concentration of H plus ion concentration, and from that you can directly calculate the pH. Okay, I'm getting answers in the chat box. All of you are saying option B, pH 3 is the answer. Let's see if that is the correct answer or not. So to solve these kind of questions, the easiest way is to use the M1V1 is equal to M2V2 formula. So we have initial volume, that is V1. We have initial concentration, that is M1. And this is equal to M2 into V2. So we have initial volume as 5 ml, initial concentration as 0.2 molar, and final volume as 1 liter. So you just have to take care that the units are same on both sides of the equal to sign. So if this is in ml, you have to write this also in ml. So 1 liter would be 1000 ml into M2, which we have to solve. So that is exactly what we have done. So you can calculate from here. M2 would be 10 raised to the power of minus 3. And when you take the log of 10 raised to the power of minus 3, it will be 3. So I told you, if you have this kind of logarithmic problem, you can split it into log 1 plus log of 10 raised to the power of minus 3. So log 1, log base 10 of 1 is equal to 0, plus log 10 raised to the power minus 3 can be written as minus 3 into log 10. So this will be, and both of them are in negative sign. So this will be log 10 is 1. So negative of negative 3 will be positive 3. So the answer would be plus 3, or the pH will be 3. Okay. All of you have responded 3 or option B as the correct answer. So I am hoping that all of you were able to solve. If anyone has any doubt in this question or regarding the calculation, please feel free to ask. Write it in the chat box. Okay. Moving to the next question, calculate the approximate pH of a buffer containing mixture of 0.25 molar formic acid and 0.1 molar sodium formate. Dissociation constant of formic acid is 1.8 into 10 raised to the power of minus 4 at 26 degrees Celsius. Okay. So we have dissociation constant given in this question. I told you dissociation constant of formic acid means Ka for formic acid is given as 1.8 into 10 raised to the power of minus 4. Okay. And we have the concentration of formic acid given. We have the concentration of sodium formate given. So which equation do you have to use here? From the first slide, you have to use the Henderson-Hasselbalch equation that I had shown. So you have to calculate the pH. You have the Ka value from which you can calculate the pKa. You have the acid concentration and the salt concentration. So sodium formate is a salt of formic acid. Okay. Everyone try to solve it. I've given enough hint to do this calculation. I hope everyone will be able to do it. People who are not responding any option in the chat box, I hope you are getting the answers. Even if you are not getting the answers as fast as others, at least try to land on the correct answer. If you are not still not getting the correct answer, I would urge you to ask me as many times as you want. This session is for that purpose only. This session is a problem solving session. If you have a problem, I am here to solve it. Okay, so I can see people are already answering. Option C, 3.35, option C. Okay, so most of you are agreeing with option C. Let's see if that is the correct answer or not. So that is the correct answer. So I told you Ka is given. So from that, first you can calculate pKa. So like you were calculating pH, similarly you can calculate pKa. pKa came to 3.74. Now using this equation, you have pH, you have pKa, and salt concentration is given, that is sodium formate. Acid concentration is given, that is formic acid. So just put all those things in the formula and solve this. You will get the answer. If you are not used to using scientific calculator and using these logarithmic equations, I would request you to practice it a few times so that you will be accustomed to it, because during exams you will have a limited time to do these calculations also. So it's better, like not just for this exam but for any competitive exams in future, it's better to do it as quickly as possible. Okay, so I can see all of you have responded option C, 3.35. There's no one disagreeing to it. That's a good thing. Still, if anyone has any doubt, please ask. This is clear to everybody? Okay. Okay, great. Then I'll move to the next question. If you have any doubt in any of the previous questions, write it in the chat box. I'll try to clear it up. Okay. Question number 5. A 300 ml of 0.5 normal HCl solution is mixed with 700 ml of 0.1 normal NaOH solution. pH of the solution is approximately. So we have acid solution HCl and we have a basic solution of NaOH. Okay. Both are strong acid and strong base. The volume and the concentration of the acid and for the base is given. You have to now calculate the pH of the final solution. So, any idea how to do it? If you are able to do it, I would request all of you to try solving it. Okay, Titli has already solved it. Option C. We'll see if that is the correct answer or not. I'll wait for others to reply. Okay, I have one option B, two option C. Okay, I have two answers in the chat box. All of you keep solving it. So I'll tell you the trick to solve it. Basically, HCl will neutralize the NaOH solution. So equal amount of HCl and NaOH will get neutralized and there will no extra H plus ion concentration for the pH to increase or decrease. Okay, so the pH that we'll get for the final solution will be from the extra H plus ion that are present in the solution, or extra cations that are present in the solution. So we have 300 ml of 0.5 normal HCl. Okay, so from this first you can calculate the moles of HCl. So whatever moles you are getting from this, moles or millimoles you will get. And then similarly you can calculate the moles of NaOH solution. Now let's say you get X moles of HCl and Y moles of NaOH. So you have to first subtract the moles of HCl from NaOH, and then the extra H plus ion concentration, the extra moles of HCl that will be remaining in the solution, that for that you calculate the H plus ion concentration, and from there you can calculate the pH. Okay, so now I can see most of you are answering option C. I have one option B also in this chat box. So the correct answer is option C, or 1.096. So the right way to solve this question is you first calculate the moles. So 300 into 0.5 would be 150 millimoles, or you can divide it by 1000 to get the moles. It doesn't really matter. And for NaOH we get 70 millimoles. So now you can see HCl is extra in the solution. So 150 millimoles of HCl minus 70 millimoles of NaOH, because uh, 70 millimoles of HCl will directly neutralize 70 millimoles of NaOH. So what will be remaining? Remaining will be 80 millimoles of HCl. Now this 80 millimoles of HCl, total volume of the solution is also increasing because we are mixing these two solutions. So 300 ml plus 700 ml, that is 1000 ml solution. So in this 1000 ml solution we have 80 millimoles of HCl. So now the question is straightforward. So that means the molarity would be 0.08 for the HCl. The final concentration of HCl would be 80 millimolar or 0.08 molar. Okay, so now you have the HCl concentration. HCl concentration is directly equal to H plus ion concentration. Once you have the H plus ion concentration, you can always calculate the pH by taking negative log of that number, and that comes to 1.096, which is option C, which most of you have answered. Somebody answered option B. I hope you have rechecked your calculation. Kavita, I hope you have rechecked your calculation. If not, you can recheck it. It's not a big deal. I'm pretty sure there must be some calculation error. So do it once more. This is the detailed solution. If you have any doubt, people who have not answered in the chat box, if you have any doubt in solving this question, please let me know. Write your doubt in the chat box, or if you're not comfortable writing, unmute and ask. I am fine with that. Unmute your mic and ask the question if you have any question. Okay, so this is hopefully clear to everyone. I'll move to the next question. Question number 6. pH of blood is 8. The ratio of bicarbonate to carbonic acid is approximately. So blood pH is given, that is 8. We have to calculate the ratio of bicarbonate to carbonic acid. So basically you have to calculate the salt concentration divided by acid concentration. This ratio you have to calculate. So from this you can get the idea which equation we have to use. So we have Ka given for the acid. So Ka is already given for the acid. So we can calculate pKa, and we can use the equation that I have shown you in the first slide and solve for this ratio. So you have pH, you have pKa. Now in this question you have to calculate the ratio. Okay. Okay, I have one answer in the chat box. Okay. I'll wait for others to calculate and then I'll show you the solution. Okay, now I have multiple answers. All of them are option C or 45. Let's see that is the correct answer or not. So that is the correct answer. So the way, actually there are two ways to solve it. The hint that I was giving you was about Henderson-Hasselbalch equation, but in the first slide I explained how this Ka is associated with the concentration of the counterions. So if I have the acid form acid H2CO3, this is basically dissociating into HCO3 minus and H plus ions. So we can write this dissociation constant as the concentration of HCO3 minus multiplied by the concentration of H plus ions divided by the concentration of H2CO3. Now this value is given as 4.5 into 10 raised to the power minus 7. pH is given as 8, so you can calculate the H plus ion concentration. That would be 10 raised to the power of minus 8. And you can replace the H plus ion concentration in this equation. From that you can get the ratio of the salt concentration divided by acid concentration. This is basically the salt concentration because this is bicarbonate ion. So bicarbonate ion to the carbonic acid. That is what we were supposed to solve. Ratio of bicarbonate to carbonic acid. So you have here ratio of bicarbonate to carbonic acid, that is 4.5 into 10 raised to the power minus 7 divided by 10 raised to the power minus 8. If you calculate this, basically you will get 110 here. So 4.5 into 10 would be 45. This is one way to solve it. Second way is what I was telling you in the previous slide, that you can use this Henderson-Hasselbalch equation where you have to now find this ratio. So you already have the pH, that is 8. You can calculate the pKa from the Ka value. So from there we are getting pKa as 6.35. So you have 8, you have 6.35, and you have this equation. So log of salt concentration of an divided by acid concentration, a log of bicarbonate to carbonic acid ratio would be equal to 1.65. So the ratio would be equal to 10 raised to the power of 1.65. If you take if you solve this, it will also come around 44.6 or 44.7, which is approximately equal to 45. So this is one way to solve it. So there are two different ways. It's completely okay, whichever approach you find it easier to use, you can use it. Okay, any doubt in this, any of the approach? If you are understanding one approach but not the other approach, then also you can ask me, because both of them are useful in one way or the other. So the concept behind the dissociation constant of acids and base, it needs to be understood, because the first approach actually uses that concept. The second approach directly uses a formula which I've told you. So if you are good with learning formulas, then you can use the second approach. If you are not very confident with that, you can use the first approach as well. Is this clear to everybody? If anyone has any doubt, please write it in the chat box. I'll move to the next question meanwhile. Question number 7. A 0.2 molar solution of a weak monoprotic organic acid is 2.3% ionized at 25 degrees Celsius. The value of Ka is approximately. Now this is something different from what we have been solving till now. So we have a monoprotic organic acid. Monoprotic acid means it has only one H plus ions, like I told you HCl is a monoprotic acid. Okay, but in this case we are talking about a weak monoprotic acid. So it's a weak acid, it's not HCl kind of situation. That's how we need to solve the Ka. Okay, so it's a weak monoprotic acid. Let's just take an example of hypothetical acid Ha, which is dissociating into H plus ions and A minus ions. Okay, the rate of dissociation is 2.3%. So this is dissociating by the rate of 2.3%. So if we are starting with 100%, after some time it will be 100 minus 2.3, that. Okay, and the starting concentration is given as 0.2 molar. So starting concentration is 0.2 molar. Starting concentration for these two will be 0. Final concentration you can calculate based on this, and based on that you will have a final concentration for H plus ion, and based on all these information you can define Ka as H plus ion concentration, A minus concentration and Ha concentration. Okay, so then you can calculate for Ka. So try solving it. If anyone is able to solve it, good. Otherwise I'll show you the solution. Okay, I have one answer, option C. Okay, I'll give some time for all of you to solve. Okay, so all of you have answered option C, 1.06 into 10 raised power minus 4. So let's see the solution and let's check if you all are right or wrong. So the final answer is 1.06 into 10 raised power minus 4. So option C is the correct answer. Now let's see how to solve this question. So the first information that we have in this question is the dissociation rate and the concentration, initial concentration of this monoprotic acid. So I told you if we start from Ha, it's a hypothetical acid, weak acid, so we'll make reversible arrows, and it is dissociating into H plus and A minus ions. Okay, what information do we have? We are starting from 0.2 molar. Initially it will be 0 and 0. After some time, what will happen after the dissociation? 2.3% will get ionized. So from this initial concentration, 2.3% will be reduced, and 2.3% of this initial concentration will be the concentration of H plus and A minus ion, because 1 mole of Ha is giving 1 mole of H plus and 1 mole of A minus. It's a monoprotic acid. So after some time, 2.3% of 0.2, okay, will be the final concentration of H plus, and same will be the final concentration of A minus ions. Okay, so that means 2.3% means 2.3 by 100 into 0.2. This will also be 2.3 by 100 into 0.2, and here we'll have from 0.2 we'll have to subtract 2.3 by 100 into 0.2. Okay, so in the explanation I've taken alpha as the dissociation rate. So this is, so here if you take 0.2 in common, it will be 1 minus 2.3 by 100 or 2.3%. So that is the alpha. Okay, so after dissociation it will be 0.2 multiplied by 1 minus alpha, and the concentration of H plus and A minus will be 0.2 alpha, 0.2 alpha. Okay. So now Ka, I told you it is written as H plus ion concentration multiplied by A minus concentration divided by Ha concentration. Okay. So we use square brackets to denote the concentration of that particular compound. So H plus ion concentration and A minus ion concentration is 0.2 alpha, and Ha concentration is 0.2 multiplied by 1 minus alpha. So when you solve this, you will get from here, you will get, you can cancel out one of the 0.2. You will get 0.2 alpha by divided by 1 minus alpha. Now alpha is 2.3 divided by 100. So even if you replace the value of alpha in this equation, you will land up on this answer. But for simplicity, since this will be very small number, even if you subtract it by subtract it from 1 or not, it doesn't really matter. So the final answer will become 0.2 alpha square, because there are 2 alpha here. So 0.2 alpha square, you can directly solve for that and you will get the answer. Any doubt in this? So I think all of you have replied option C. People who haven't replied any answer, I hope now you are able to calculate this. Please let me know if you have any doubt. If you don't understand this, I can explain it again. Okay. If there is no doubt, then I think I can move ahead with the next question. Question number 8. Calculate the mass of NaF that must be added to 300 ml of 0.25 molar HF solution to form a buffer solution having the pH 3.5. So you have to calculate the mass of this salt NaF, sodium fluoride, that must be added to 300 ml of the 0.25 molar acid solution to form a buffer solution of pH 3.5. Dissociation constant of HF is given, molecular weight of NaF is given. So we have dissociation constant Ka for HF. It is given. We have pH in the question. From Ka you can calculate pKa. We have pH in the question. So, and we have the acid concentration in the question. Okay. And we have to calculate the mass of the salt. So first you calculate the concentration of the salt, and then using this molecular weight of the salt, you can calculate the mass of the salt. Let's see if anyone is able to solve this. All of you try solving it. Even if you are not able to solve it, it's okay. It's just a doubt clearing session. I'll help you solve this question. But try to solve it, at least try. All of you give it a try. Write the answer in the chat box. I'll wait for the answers and then I'll discuss the detailed solution. Okay, I have one answer, option C. Okay. What about others? 7.21 gram. Okay, that is closer to the option C, but that is not the exact answer. I think you should get more close to the correct answer. Okay. Okay, others are also answering option C. Let's see if that is the correct answer. And Maisha, you have gotten something which is around that answer. Let's see. So 7.06 is the correct answer. So I've already explained how to calculate the salt concentration. So I hope till this point everyone is able to solve the question. We have the Ka given, so you can calculate the pKa. We have the pH, we have the acid concentration. So from this equation you can solve for the salt concentration. I hope this part is clear. After this, so salt concentration that we have got is 0.56 molar. This means it has 0.56 moles per liter of solution. Now what is the volume of solution we have? So this basically means in 1 liter solution we have 0.56 moles of NaF, right? This is the meaning of 0.56 molar. Now the volume that we have is 300 ml or 0.3 liters. Okay, so if in 1 liter 0.56 moles are there, then in 0.3, just normal unitary method, then in 0.3 liter it will be 0.3 into 0.56 moles. Okay, so now you have the number of moles. Now 1 mole is equal to the molecular weight in grams. Okay, molecular weight is basically grams per mole. So 1 mole has 1 molecular weight, whatever the molecular weight. In this case, the molecular weight given is 42. So 1 mole of NaF will have, 1 mole of NaF will have 42 grams. So now 0.3 into 0.56 moles will have 0.3 into 0.56 into 42 grams. Just calculate this and you will get the answer 7.06. I hope this is clear. Okay, there are 2 people who are getting 7.21. Can you check your calculation once or let me know how you are getting 7.21 so that I can identify your mistake and help you out? How you are getting 7.21? I hope I haven't done any calculation mistake. I'll also check once. 0.3 into 0.56 into, we have 42. Yeah, 7.056 is the exact answer. 7.056 is the exact answer. How you are getting 7.21? Check your calculation again and ask if you have any doubt. Is it clear now? Especially people who haven't responded, is it clear to you? If there's any doubt in the calculation or if there's any doubt in the concept, please ask. And Shanunda and Maisha, are you able to get this answer? Because you both have written 7.21. Okay, let me know if in the chat box if you have any doubt. Okay, very good. I'll move to the next question in that time. If anyone has any doubt in the previous questions, please write it in the chat box. Question number 9. Say 15 ml of 0.2 molar HCl is diluted to 1 liter. The pH of the final solution will be approximately. So we have already calculated such type of question. So it's just another similar question with different values. So this should be solved by everyone quickly. We have 15 ml initial volume, 0.2 molar initial concentration, 1 liter is the final volume. Calculate the pH. Quickly calculate, everybody, and tell me the answer in the chat box. Option D, 2.52. Okay. 10, 3. Okay, I see a lot of responses and all of them are option D. So let's see if that is the correct answer. That is the correct answer. So initial volume is 15 ml. Yeah. Initial volume is 15 ml. Initial concentration is 0.2 molar. Final volume is 1 liter. So since this is in ml, we have to write this also in ml. So whenever you are writing this equation, just make sure you are using the unit. So if you are taking this as molar, this will also be in molar. If this is in ml, this will also be in ml. If this is in liter, this will be in liter. If this is in millimolar, this will be in millimolar. So that you have to check that the LHS is equal to RHS. Okay. Rest, just calculate 15 into 0.2, that is 3 divided by 1000. So 3 into 10 raised to power minus 3, and we'll have log 3 plus 3. So this will be negative. So 3 minus something you might have got, which will give you 2.52. Okay. Clear to everybody? Most of you have written 2.52 as the correct answer. So I think this is straightforward if we have already solved such question. Okay. Moving to the next question. There is a buffer solution containing 0.1 molar solution each of ammonia NH3 and ammonium chloride NH4Cl. Final pH of the buffer solution upon adding 0.01 moles of HCl in 1 liter is approximately. So there is a buffer solution containing 0.1 molar solution each of NH3 and NH4Cl. Okay. And final pH of the solution upon adding 0.01 moles of HCl in 1 liter solution. So we have a volume given in the question. We have moles of HCl that is added. We have the concentration of both ammonia and ammonium chloride. In this case, just to give you a hint, because we have been dealing with acidic solutions till now. So this is a basic solution. That's why we have the pKb value given. So in this case, use the pOH formula. Okay. Try to calculate the pOH first and then calculate the pH by directly subtracting it from 14. Okay. So pH is equal to 14 minus pOH. Okay, this is just one hint since we are dealing with this type of question for the first time in this session. And pKb is already given, so this you can use the Henderson-Hasselbalch equation. In this case, one more information, NH3 would be the base, and this is the base, and NH4Cl is the salt. So NH4Cl is basically the salt of ammonium ion and the chloride ion, right? So chloride ion comes from HCl. Okay. So use the equation, find pOH. Now, okay, the trick is you have to find the pH after the addition of HCl. So first you have to calculate the moles of NH3 from the molarity. You have the volume, so since the volume is 1 liter, moles would be same. So 0.1 moles of NH3 and zero point 0.1 moles of NH4Cl. From that, you will have to subtract and add the moles of HCl. So the HCl would be added, the concentration of HCl would be added to the salt and subtracted from the base, because HCl is going to neutralize the base, so reduce the basic concentration, increase the acidic concentration, and the final concentration of salt and base you will use and find the pOH. Has anybody been able to solve? Ma'am, could you please show us the previous solution to this question? This one, are you asking?
Yes, ma'am. Thank you, ma'am.
Yeah. Is it okay, or you want to you want me to wait on the slide for some time?
No, no, ma'am. It's okay.
It's
Thank
okay.
you, ma'am.
Yeah, yeah. Okay. Okay. Try solving this question, everybody. Try to at least find pOH. Once you find pOH, just subtract 14. Just subtract it from 14. You will get the pH. Write your answers in the chat box. I'll wait. Okay, we have option A as one answer. pOH is 2.8. Okay. What about others? Okay, we have one more answer, option C. Okay, I think you are having some difficulty in calculating. I'll show you the solution for this. All of you can follow that solution. So the correct answer is 9.18, option A. So since very few people have responded, I'll show you the detailed solution. So when we add 0.01 moles of HCl, so it is in 1 liter solution, so moles and molarity would be same. For NH4Cl and NH3, the initial moles were 0.1, right? Initial moles were 0.1. Now, when you are adding HCl, HCl concentration will be subtracted from the base because it is going to neutralize the base. It is reduced. It is going to reduce the basic concentration because HCl is an acid. So the base concentration will be decreasing. So 0.1 minus 0.01 moles of HCl. This will be the final moles of NH3, and it is in 1 liter. So this will be in molarity only. And again, the for NH4Cl, so this is basically the conjugate acid, you can call. Okay. And when you are adding HCl, it is going to dissociate into H plus ion and Cl minus ions. Cl minus ions are going to increase the concentration, overall concentration of the salt, and H plus ion is going to decrease the concentration of this base. Okay. So the concentration of salt will be increased by 0.01 moles, and the final molarity of the salt would be 0.11 moles. So now, simply using this equation, pOH is equal to pKb plus log of salt concentration divided by base concentration. So in previous questions, we were using the first form of Henderson-Hasselbalch equation, where we were calculating the pH by using the pKa value, and we were using acid concentration in the denominator. Same thing we have to do, only in this case we are calculating pOH. We are using pKb value, which is given in the question. Now we have the salt concentration and base concentration. So just replace the values in this equation and you will get pOH. Once you get pOH, just subtract from 14 to get the pH value. Is this clear? So I see two more people had responded 9.18. So I hope others will also be able to get this answer. If anyone has any doubt in this question, please write it in the chat box or unmute and ask. Okay. So the correct answer is 9.18. That is option A. I'll move to the next question. Question number 11. What volume of 0.2 molar sodium formate solution should be added to 100 ml of 0.02 molar formic acid to produce buffer solution of pH 4, given pKa of formic acid? So very straightforward question. You have the sodium formate, that is the salt. You have the concentration of the salt. You have the concentration of the acid. You have pH. You have pKa. And you have to calculate the volume. So now in this case, you have to again uh, calculate the moles first, and then you have to come to the equation, Henderson equation. Okay. So try solving it on your own and then I'll show you the solution. I'll wait for some time for everyone to calculate and respond. It might be little long to calculate. You might get a equation, a quadratic equation kind of a thing. Just try to solve how much ever is possible. Meanwhile, I'll also show the solution so that people who are not able to solve it can follow it along with me. So we have to calculate the volume, right? So let's assume that the X volume of sodium formate, 0.2 molar sodium formate, is added to the 100 ml. So the final volume will become 100 plus X, right? So now based on this, the concentration of sodium formate and formic acid will also change. So the initial concentration of sodium formate is 0.2 molar. So 0 x ml of 0.2 molar is added to 100 plus x ml. So that will make the final concentration as, so normal m1 v1 m2 v2 we have to do. So we have x ml, okay, of 0.2 molar. Final volume is 100 plus x ml and final concentration. So final concentration m2 would be sorry, m2 would be 0.2x by 100 plus x. So this will be the concentration of sodium formate. Similarly, to solve for the concentration of formic acid, you will have 0.02 molars of formic acid, that is the initial concentration. Initial volume is 100 ml. Final concentration would be M2 into final volume is 100 plus X. So it would be 0.02 into 100 would be 2 divided by 100 plus X. So this will be the concentration of acid. Okay, so now you have the salt concentration, acid concentration, pH, pK, everything is given. Now you can replace all these things in the equation. So once you replace it in the equation, it is going to become little tricky. So take your time to calculate it. I see some people have calculated it and they are getting 15.84 as the answer, which is the correct answer, option A. Yes, so some people have been able to calculate it. It's okay even if you haven't calculated it. I hope your strategy was correct. You can take your time calculating the whole thing, but at least I hope you have landed on this kind of equation. That is important. Okay, this is clear to everyone. If you have any doubt, let me know. I'll move to the next question. Calculate the dissociation constant of weak acid HA. Its degree of dissociation is 10 degree of dissociation of 10 raised to power minus 3 molar, solution being 10%. So this is similar to the question that we have solved. What is the approximate pH of the solution? So we have to now calculate for dissociation constant and pH. So it is already we have solved for this question. So quickly I'll give you a recap. So if I have a weak acid, I'll have H plus ion and A minus ion counter ions. So the starting concentration is 10 raised to the power minus 3 molar, and here we'll have 0. After dissociation, 10% of this is being dissociated. So this will be 10 raised to the power minus 3, 1 minus 10%, and this will be 10 raised to the power minus 3 into 10%. This is also 10 raised to the power minus 3 into 10%. So 10% means 10 upon 100. So just solve this. From this you can calculate for Ka. Ka will be H plus ion concentration, A minus concentration divided by concentration of Ha. So just take these values and put it in this equation. You will get Ka, and H plus ion concentration is basically 10 raised to the power minus 3 into 10%. So from this H plus ion concentration, you can directly calculate pH. Okay. So we have already solved this question, so everybody should be able to solve it. We have already solved this kind of question whether only the values were different, that the dissociation constant was around 2.3. Here it is 10%. So now you cannot ignore it from the denominator like we did in the previous case, but rest of the things are fairly simple. Since it is 10%, the calculation is easier. You don't even need a calculator. Sneha has answered option C. Are you sure it is option C? Option C, option B. Okay, let me also check. So the correct answer is 1.11 into 10 raised to the power minus 5. Okay, option C is the correct answer. What about others? Are you able to calculate this? We have already calculated this type of question, right? You had answered in that case, so you all should be able to answer in this case as well. Okay. Trisha, you are getting option B as the answer. Can you check your calculation once? Yeah, now I can see other people are also answering option C. So I hope all of you get the correct answer as option C. So it is same as the previous question that we had solved. So we have alpha is 10%, so 10 divided by 100, so or 1 by 10 or 0.1. So just replace 0.1 in this equation and then you will get this answer. And for H plus ion concentration, 10 raised to power minus 3 into 0.1, that is 10 raised to power minus 4, and log of 10 raised to power minus 4 would be 4. Okay, all of you are getting option C as the answer except one person. I hope you have rechecked your calculation. Let me know if you have any doubt. Others who are not responding at all, let me know if you are not understanding this, or it's just your choice of not answering. I You answer it or not, it doesn't matter, but then you have to get this answer correctly on your notebooks. That is the only thing. Kavita, you have also responded option B. Can you recheck your calculation? Trisha and Kavita, it should be option C. Recheck your calculation. I think there must be some calculation mistake. There's a lot of decimal places, so it can happen. So instead of opening this 10 raised power minus 3, I would rather solve it directly by keeping it in the uh, exponential form. So 10 raised power minus 3 into 0.1 this is whole square divided by 10 raised power minus 3, 1 minus 0.1. So 1 minus 0.1 is 0.9. And then you can solve for this. So this is also 10 raised power minus 1. So this whole thing becomes 10 raised power minus 4 into 2. So this will be 10 raised power minus 8 divided by 10 raised power minus 3 into 0.9. So minus 8. So this will be minus 5. So 1.11. 1 divided by 0.9 is 1.11 into 10 raised power minus 5. Just recheck your calculation. You might have made a mistake while taking the denominator to the numerator part. Check your calculation. I hope you will get the answer. Moving to the next question. Approximate pH of the buffer solution containing 0.5 molar solution each of ammonia and ammonium chloride is. So you have to calculate the pH where the concentration of ammonia and ammonium chloride is given, pKb is given. So this is again a very straightforward question. We have been discussing this question. The only thing is pKb is given, so now you know what to calculate first. Can you calculate pH in this question? You have to calculate the pH, but can you directly calculate pH in this question, or you have to first calculate something else and then you have to calculate the pH? Quickly do this question. The calculation for this is also very simple because the salt and base concentration is same, so you should be able to get the answer quickly. Concentration of salt and base is same, so log of 1 is 0, just if you don't know. Okay, Swastika is already calculated. What about others? Okay. Okay, most of you have answered 9.24 or option B. That is the correct answer. So for this, the calculation becomes even easier because first you have to calculate POH, right? So POH will be pKb plus log salt upon acid concentration, right? This won't be here. Uh, so you have pKb given as 4.76 log of, now salt and acid concentration both are 0.5. So this makes 1, 0.5 by 0.5. So this will be 1 and log 1 is 0. So your POH will be equal to 4.76. So pH will be equal to 14 minus 4.76, that is equal to 9.24. Okay, this is the solution. Ma'am, I have some doubt from the assignment questions. May I ask now? Uh, can I finish the session because I have made all the questions related to your assignment questions. So I think if it hasn't come up till now, it will come up. So can you wait till the end of the session? Yeah, thank you. So this is the solution. I think there should not be any doubt in this. Still, if you have doubt, please ask in the chat box. I'll try to help you. Moving to the next question, question number 14. An acidic buffer mixture is made of HA and NaA of total molarity 0.45. Solution has the pH 3.5 and HA has the dissociation constant of 1.8 into 10 to the power minus 5. The approximate composition of the buffer in terms of concentration of salt and acid respectively. So you have to calculate the concentration of salt and concentration of acid. The information that is given to you regarding this is the total concentration of salt and acid. So you have salt plus acid concentration given as 0.45 molar. Okay, you have Ka, so you can calculate pKa. You have the pH, so just replace it in the Henderson equation, where you can either assume salt concentration or acid concentration as X. So if you take salt concentration as X, then acid concentration would be equal to 0.45 minus X, and then replace these values in the Henderson equation and you will get the answer. First calculate pKa, take the negative log of this and then replace these values. If you are taking acid concentration as X, then salt concentration would be 0.45X. In both cases, you will get the answer. And once you get the value of X, calculate the value of 0.45 minus X also. So you will get whatever you have assumed. If you have assumed salt concentration to be X, then salt concentration and acid concentration. So first values are salt concentration and second values are acid concentration. So check your answers in the options and write it in the chat box. It should not take a long time now. We have been solving these questions since almost 1.5 hours. So now you should pick up some speed while doing the calculations. Anybody? Okay, I'll also show you the solution. So as I've explained, let's say the salt concentration is X, then acid concentration would be 0.45 minus X, and then same whatever you have done in the previous question, same thing you have to do. calculate pKa first. So pKa would be negative log of 1.8 into 10 raised to the power minus 5. Once you get this, you have to subtract pH from pKa and then take a power 10 of the whole thing. So you will get the ratio x divided by 0.45x. From that you will get the value of x. So value of x was basically the salt concentration, and the acid concentration would be 0.45 minus x. So the correct answer is option B. Are you guys following this? This should not take this long. I thought this was very similar to all the other questions that you were solving. You all were solving very quickly, so what happened? Did you stop solving, or did you, like, are you not able to solve it? Come on, ask if you have any doubt. Otherwise, here's the solution. I hope this is clear. Let me know if you have any doubt. Write your doubt in the chat box. I'll move to the next question. Question number 15. pH of a water sample containing 2.4 into 10 raised to the power minus 3 molar hydroxide ion is approximately. So OH minus concentration is given. So this is given as 2.4 into 10 raised to the power minus 3. And you have to calculate pH. So again, I think this is simple. Solve this quickly. You have OH minus concentration. So what you can calculate from that? You can calculate POH. Once you have POH, you can calculate pH. Calculate this quickly. Option D. Yes, that is the correct answer. So I was also calculating. So option D is the correct answer, 11.38. So this is very straightforward. You have the OH minus concentration, so you can calculate POH by taking the negative log of that. POH comes to 2.62. pH will be 14 minus 2.62, that is 11.38. Okay. Most of you got the answer, so I'll not waste time on this question now. If you still have any doubt, please ask. Next question is also very simple. Calculate the approximate pH of a solution containing 10 raised to the power minus 2 molar H2SO4 solutions. So H2SO4, so till now we have been solving questions for monoprotic acid. The only difference is we have two protons now, 2 H plus ion. So one H2SO4 will dissociate into 2H plus SO4 2 minus. So the concentration of H2SO4 will not be equal to the concentration of H plus ion, unlike in case of HCl. In case of HCl, we were having H plus and Cl minus. So if the concentration of HCl was 1 molar, concentration of H plus was also 1 molar. But in this case, if the concentration of HCl is H2SO4 is 1 molar, concentration of H plus ion will be 2 molar, because it is in 1:2 ratio. Okay, so that is the only difference. So the concentration of H2SO4 is given, so you know the concentration of H plus ion. Calculate the pH. Okay, option D. I'm getting responses option D. That is the correct answer. So 10 raised to power minus 2, if we have for H2SO4, the H plus ion concentration would be 2 into 10 raised to power minus 2. This would be H plus ion concentration. So pH would be negative log of 2 into 10 raised to power minus 2. So log 2 would be 0.301. So negative 2 minus 0.301. That would be your answer. So that is 1.7. I hope everybody got this answer. I can see 3, 4, 5. Okay, most of you are getting this answer. Very good. Again, this is also straightforward, so I'm rushing through these questions because I think we have solved enough questions related to this. Still, if you feel that I'm going very fast, please let me know. I'll slow down. Moving to the next question. Okay, this is an important question. We'll take time on this. A buffer solution contains 450 mg per liter acetic acid and 150 mg per liter of sodium acetate. Approximate pH of the solution after addition of 15 mg per liter of HCl is. So we have solved one question like this where we were adding HCl to the buffer solution and then calculating the final pH. So this is similar to that question. If you recall the question, you should be able to solve this. The only difference is in that question we had moles or molarity given. In this question we have concentration given in terms of mg per liter. So you have to take the molecular weight of acetic acid, sodium acetate and HCl into consideration. So I hope you know the molecular weight of acetic acid, sodium acetate and HCl. Molecular weight of acetic acid would be 60. For HCl it would be 36, and for sodium acetate it would be 60, I think 83 around. Check once. (82). Molecular weight of sodium acetate is 82. Acetic acid is 60. HCl is 36. Use this information and calculate. So we have 450 mg per liter of acetic acid, right? That means the molarity or the concentration in terms of molarity, if you have to calculate, it would be 450 divided by 1000 to convert it in gram and divided by 60, which is the molecular weight. So this will be the moles. Okay, moles or molarity. Okay, in this case, since we are talking of 1 liter solution, so it doesn't matter. So moles or molarity. So this will be moles of acetic acid. Similarly, you calculate the moles of sodium acetate. That would be 150 by 1000 into 82, I said, right? So just check if it is 82 or 83. So this will be moles of sodium acetate. Now you are adding HCl. So if you are adding HCl to this acidic buffer, what will happen? It will increase the molarity of the acid and decrease the molarity of the conjugate base. So the acid concentration to be used in the Henderson equation, the acid concentration will increase from 450 divided by 1000 into 60 from this to what is the HCl molarity? HCl would be 15 by 1000 into 36, I think. No? So just add these two, this and this, add and subtract from this value you have to subtract from this and add it in this. So that would be the final acid concentration and salt concentration. Put it in Henderson equation, you have the pKa, you will get the pH. Is anyone able to solve this? Should I show you the solution or you're still trying to calculate? I'll wait for a minute and then I'll show. I've already told you what to calculate. Just use your calculator and do this calculation, whatever is written on the screen, that will also give you the answer. Nobody? Okay, let's see the solution then. So here is the solution. As I've told you, the acid concentration, initial acid concentration is 450 divided by 1000 into 60. It is coming to 75 millimolar or 0.0, sorry, 7.5 millimolar or 0.0075 molar. Similarly, salt concentration is 0.0018 molar. Now HCl concentration that is being added is 0.0004 molar, so or 0.4 millimolar. So if you now subtract the HCl concentration from sodium acetate, that will be 0.0018 minus 0.0004. So you will get the final salt concentration, and if you add the HCl concentration to the acetic acid, you will get the final acid concentration. Then simple Henderson-Hasselbalch equation where pH is equal to pK is already given, plus log of salt concentration divided by acid concentration. The calculation might take time, but you should be able to land on an answer. I see one answer in the chat box at least, that is B. Yes, that is the correct answer. Samajita is also close for 3.99 since your option had 3.99. So these were the options. So even if you are getting 4, Trisha, you are getting 3.82. I think the answer shouldn't be this far from the options. So Trisha, I would request you to check your calculation once. Maisha, the correct answer is option B. So you also check your calculation once. I'll open this solution slide. All of you go through this and check your own calculation. And see if you can point out the mistakes you are making. Mobani and Samadita, you have gotten the right answer, so it's good. Rest of you who haven't answered also check this calculation. Trisha and Maisha, I request you to go through your calculation once. Other than the calculation part, is there any doubt in this question? Others who haven't responded anything, any answer, is it clear to you? the solution. You can take your time, do the calculation slowly, practice it. Okay, you got 3.98, very good. uh, Everybody check your calculations. I hope the solution is clear enough. Anyone, if you have any doubt, please tell me. I'll move to the next question. I have two more questions, so I'll quickly cover it up. Approximate pH of 0.25 molar solution of sodium nitrite NaNO2 is. So here, this is the question where you can use the uh, pH for salt concentration, formula for pH for salt salt for particular concentration. So NaNO2 is a salt of weak acid, HNO2 is the weak acid, and NaOH is a strong base. So you have the concentration C for the salt solution, that is 0.25. You have pKa. So you can directly use the formula for calculating the pH of a salt solution and calculate. So that was, the formula was 1.2 of pKw plus 1.2 of pKa, I think, and plus 1.2 of log C, if I'm not wrong. Ma'am, explain about the consumption of sodium acetate. Okay, I have a question from the previous slide, requesting all of you to calculate this. Calculate the pH of NaNO2, whose concentration is 0.25 and pK is 4.5. Till then, I'll explain this. Samadrita's question. Her question is how sodium acetate is being consumed. So now in this question, we are adding acid. Okay, we are adding HCl. So what will HCl do? HCl will dissociate into H plus ion and Cl minus ions. Now in a buffer solution of CH3COOH and CH3CONA, what we'll have? We'll have extra Na plus ions, because CH3CO minus ions are the common ion. So there will be common ion effect. H plus ions, these H plus ions will be added to these existing H plus ions. So I'll write everything down. So CH3COH will dissociate into CH3COO minus plus H plus, right? So when we are adding HCl, it is directly adding the concentration of H plus ion. So we have to add the concentration of HCl to the concentration of acetic acid. Now when we are taking CH3CONA, what do we have? We have CH3COO minus plus Na plus. So now if you have chloride ions, the Na plus will get neutralized by the chloride ions and the effective concentration of CH3CONA will reduce, because now it is taking up the sodium ions, right? Chloride ions will take up the sodium ions from the solution and decrease the effective concentration of this, whereas H plus ions will go and add in the existing H plus ion pool and increase the effective concentration of the acid. Okay, is this clear, Samadrita? If it is not clear, it's okay, you can tell me. Okay, you got it, very good. Then this question, did anyone solve this question? You just have to put the values in the formula. You have the pH, pKw value 14, you have the pKa value 4.5, you have the C, that is 0.25, take a log and divided by 2. Okay, Kavita got the answer, option C. Let's see if that is the correct answer or not. It is not the correct answer actually. I hope I wrote the formula correctly. Yeah. So the correct answer is coming to be 8.95. So yeah. Okay, now most of you have responded 8.95 or option D. Option D is the correct answer. So Kavita, just check your calculation once. So you have 1 by 2 or zero point 0.5 of pKw, that is zero point 0.5 of 0.5 multiplied by 14, that will be 7. Then 0.5 multiplied by 4.5, and then you will have log of C, so log of 0.25 multiplied by 0.5 or divided by 2. Okay, just add all these up, you should get this answer. If you're not getting this answer, recheck your calculation. I'm sure there is a very small calculation mistake that you will be able to fix. Okay. Okay, the next question is approximate pH of a buffer solution prepared by mixing 6.25 grams of KH2PO4 and 26.25 grams of K2HPO4 in 1 liter of water. So again, this is similar to what we have been solving. So I think by this time you will be able to solve this question. So in the interest of time, I'll skip this question. I'll request who was asking? Samadrita, you had some doubt regarding the assignment questions. First, since we are running out of time, I would request you to first ask your doubt. Or is it cleared in one of these questions?
Ma'am, one question has been cleared. And ma'am, there are some two more questions which I have doubt.
Okay.
One is that calculation of the equilibrium pH of a solution containing 10 to the power of minus 3 m of H2SO4, sulfuric acid.
You have to calculate the pH.
Equilibrium pH of a solution
So you have to.
containing.
So it is similar to the question. We have calculated the pH for H2SO4 now. It's similar to
But
that question.
ma'am, after solving the question, the answer which I am getting, it's not similar to like I have searched the answer and it is not coming same. So that's why.
Okay. What is the concentration value of H2SO4?
It's 10 to the power of minus 3 m.
10 to the power of minus 3 molar, right? So 10 to the power of minus 3 molar of H2SO4 will give you 2 into 10 raised to power minus 3 H plus ion concentration, right?
Yes, ma'am.
And then you take a negative log of that. Is there any other information given in this question? No, right?
No, ma'am. No, ma'am.
So just take a negative log of that. So negative log of 2. I think even my question had the same uh, values. So here I had taken 10 raised to power minus 2. In your question, you have 10 raised to power minus 3. So it will be 3.01 minus 3. Okay.
Okay, ma'am. I guess
Yeah.
I did some calculation error.
The answer should be around 3 minus 0.3, something like that. So check.
Okay, ma'am.
Yeah. Uh, any other doubt do you have? Like, if you have any other doubt in any of the questions? Okay. I hope you will be able to solve this question. So this is similar to the one where we calculated the moles from the by using the molecular weight. So molecular weight of KH2PO4 and K2HPO4, you can search it on web. Generally in such questions the molecular weight will be given. So calculate the concentration depending on the molecular weight, and then just use the uh, Henderson equation to solve the pH. Yeah, Samadrita, do you have more questions?
Yes, ma'am.
Yeah.
Ma'am, during the class, ma'am actually explained one of the theories
Mm-hmm.
where like pK value of acetic acid came to be 4.74
Mm-hmm.
and the pKb value of NH4OH3 came to be 4.74. Ma'am, how are they both same?
They can be same, right? pK and pKb value is basically the equilibrium. It's a equilibrium constant. We are calling it a dissociation constant, but whenever you have any molecule, like if it is an acid then Ha, or if it's a base then AOH, it is basically dissociating into H plus and A minus ion, or in this case it is dissociating into A plus and OH minus ions.
OH. Yes.
And then depending on the concentration of these individual ions and the initial concentration of your acid, you can get the pK and pKb value same for two different compounds. It's two different compounds, two different uh, conditions, so that's not a surprising thing. I
Okay,
hope
ma'am.
that is clear. So for this case you will have pKa as H plus concentration multiplied by A minus concentration by
Right. HA
HA
concentration
concentration. For the second case, you will have pKb as A plus concentration
with
OH
OH
minus
minus
concentration divided by AOH
OH
concentration.
concentration.
So it can happen.
Okay, ma'am.
Depends on the concentration. Okay.
Okay, ma'am.
Any other doubt?
No, ma'am.
Okay. Anyone else has any doubt in any of the assignment questions or any of the topics discussed in the lectures or any of the questions that I have discussed just now? If you
Ma'am,
have, yeah,
once can you explain the mechanism of buffer?
mechanism of buffer, how it is maintaining the pH.
Yes, ma'am.
So I'll just take this blank space. So a buffer is basically a solution of a weak acid and its conjugate salt. So uh, let's say we have a acetic acid buffer. That is the most common example. So acetic acid is a weak acid. Okay, so it is going to dissociate slowly. It is going to dissociate slowly, and it is going to dissociate into CH3CO minus and H plus ions. And now we are making the buffer with the counter ion. So whenever we are taking a weak acid, we will take a conjugate salt of that. Conjugate salt means the salt should be made of that weak acid and a strong base. Okay. So NaOH is a strong base. So we take the counter ion sodium and we have the acid component of this. Why do we do so? So that we have this common ion here, CH3CO minus, and we'll have Na plus. Now, if we have a buffer of these two solutions, what will happen? CH3CO minus concentration will be obviously high. To balance that, we have some H plus ion concentration to this when we are adding a small amount of acid or base. Let's say, so definition of a buffer is a solution in which a small amount of acid or base, when it is added, it does not change the pH of that buffer. Okay, so if I'm making a buffer of pH 5, if I add a very small amount of HCl or any other acid, acetic acid or any other acid, the pH should not change. The pH should remain stable in that particular range. So that is defined, that solution is defined as buffer. You have the titration curve, I'm sure it's there in the lecture videos, so you can see how buffer behaves. So what happens, why the pH does not change? So this is a acetic acid buffer. Now if I add a small amount of H plus ions, what will happen? Since we have enough CH3CO minus ions, there's a common ion here, CH3CO minus, small amount of H plus ions will be immediately neutralized by these CH3CO minus ions. Okay, and since this is a strong counter ion, if I add a small amount of base, that means if I introduce OH minus ions, Na plus will immediately capture and H plus ions will immediately neutralize these OH. So H plus ions and OH minus ions will become water. So it is not going to change the pH. So basically, small amount of acid or base when added to a buffer solution, it's not going to disturb the pH of the buffer. Why? Because we have a common counter ion, and the important part is to use a weak acid. Why we are using weak acid? Because I've told you that weak acids and weak bases have a slow dissociation in the solution. Same thing will not happen if you take a strong acid or a strong base, because strong acid will immediately dissociate in the solution completely. Okay. The reason that I make this double arrow or reversible arrow for weak acids and weak base is because it is slowly dissociating and reaching an equilibrium. So we'll have the concentration of CH3COH and CH3CO minus ions in equilibrium. It will not be equal, it will be in equilibrium. But in case of strong acids like HCl, we'll have equal concentrations of HCl and equal concentration of H plus ion. Okay. So that's why using a weak acid is important. Same example can be explained for a weak base, where you can take, like we had the example for ammonium chloride. So NH4Cl is the salt and ammonia is the weak base. Ammonia is the weak base. Okay. So ammonia will dissociate into ammonium ion and hydrox. So ammonia, basically ammonium hydroxide is the base. So NH4OH is the base. Sorry. NH4OH is the base. Okay, so it will dissociate into NH4 plus and OH minus, and NH4Cl will also dissociate into NH4 plus and Cl minus. So small amount of H plus ions will immediately get neutralized by these OH minus ions, and small amount of OH minus ions will immediately be neutralized with these common ions. Okay, and the pH will not change drastically. Is this clear? Week 2 assignment questions I'll discuss only in the next session. This session is for week 1's questions. So wait till next Tuesday to get the answers for that. Anything else? Any other question?
No, ma'am. Thank you, ma'am, for explaining.
Okay. Anyone else has any doubt? If we don't have any more questions or any more doubt, I think I can wrap the session up. Let me know. Anybody has any doubt? So we'll have this class every Tuesday, 7 to 9. So I request all of you to join every class so that you get an idea of how to solve these assignment questions. I'll try to make the questions as close to your questions as possible so that it's easier for you to solve. Any other questions? Okay. If there are no more questions, I think I can end this session. Thank you so much for joining. And I'll share these slides and the recording of this meeting with you all. You will find it in the NPTEL portal only, course portal. So you can access through the slides anytime you want. I'll discuss the week 2's question in the next session next Tuesday. So see you all. Thank you so much for joining.
Thank
Bye
you,
bye.
ma'am.
Yeah, bye bye.
Thank you, ma'am.
Thank you.